Here's problem 432, an alternate method. A tennis player standing 12.6 meters from the net hits the ball 3 degrees above the horizontal. To clear the net, the ball must rise at least 0.33 meters. If the ball just clears at the apex of its trajectory, how fast was the ball moving when it left the racket? So here's the net, and we are going to shoot this to clear the net at the apex. So that displacement at that moment is going to be 0.33 meters. And of course our x displacement is 12.6 meters. The angle of this trajectory is 3 degrees. I don't like what I just did there. And so, what do we know? Let's look at the y direction first. We know that we don't know our initial y velocity. It's going to be v naught sine theta, or v naught's our initial velocity, but we don't know what that is. We do know our final y velocity at the net is going to be 0 because we reached the apex. Acceleration is going to be a negative 9.8 meters per second squared. Displacement will be 0.33 meters. And we wish to find time. So we can use these last 4 variables to figure out the time to the net. In other words, displacement is going to equal final velocity times time minus 1/2 acceleration times time squared. And we have then that since our final velocity is 0, this is displacement is equal to a negative 1/2 times a negative 9.8 times time squared. So time squared is going to equal 0.33 divided by 4.9, or t is going to equal the square root of that. And that's going to be equal to 0.259 seconds. So that's the time it takes for the ball to get to the net. Good to know, because now we want to look at the x direction. What's going on there? Well, we know that our time is 0.259 seconds. We know that our acceleration is 0. We know that our displacement is 12.6 meters. And we really want to find our initial velocity. So let's do that. Well, if we look at that, we can try displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. But in this case, we know our acceleration is 0, no acceleration in the x direction. And so our initial velocity in the x direction is going to equal our displacement divided by our time. 12.6 divided by 0.259 seconds, and that's equal to 48.55 meters per second. That's our initial x velocity. That initial x velocity should be equal to the initial velocity that we shot with times the cosine of our launch angle. So our initial velocity that we shot with is going to be equal to our initial x velocity divided by the cosine of theta. So that will be 48.55 divided by the cosine of 3 degrees. And that's equal to 48.62 meters per second. So that indeed is the velocity off our racket, 48.62 meters per second.